All right, going on to example 4. This one is kind of funny. So this one is like silly. So here's how I'm going to do it. This looks confusing as can be, but it's really not that big of a deal. The first step I want to show you on this, I'm going to keep my ink black on this example. What I'm going to do is I'm going to tell you this is the exact same thing. Even though this doesn't look like the exact same thing, and you're like, huh? And your brain might be freaking out. Trust me that it's the exact same thing. So watch this. I'm going to go ahead and start. I'm going to start by looking at my tops. My tops are 10 and 4. So I'm going to put my 10 here. I'm going to put my 4 here. And what's my goal? My goal is I'm trying to get a common denominator, y'all. Check out this 2. Mister, there's no denominator on a 2. That is a lie. Straight up. There is a denominator there. You just can't see it. It is a 1. Now, we don't care about multiplying 1 in the denominator, right? We don't need to worry about that. So 1 is kind of a dead thing. You can add it if it helps your mind work, but it's not necessary. But it doesn't matter. So we'll see it. With that said, I'm going to look at this. So my denominator is 3, an x, and a 1. Again, do I really want to write 1 times 3? No, because that's just 3. Do I want to write 1 times x? No, because that's just x. So we're not ignoring the 1. We're not ignoring the 1. It's just redundant. So I'm going to go ahead and start here. I have a 3 down here. I have an x down here. And I have my 1 here. So I'm going to go ahead and start that way. Now, I need to multiply these all together. So 3 times x times 1. So I should have an x that gets added down here. And then a 1 that should get added down here. And again, I know it's redundant, but for now, I'm just going to model it. So now 3 times x times 1 is my common denominator. So now I'm going to look at here. I got the 3, I got the x, and the 1. On this side, I have the x, but I need the 3, and I need the 1. On this side, I have the 1, but I need the 3, and I need the x. All right, cool. So with that said, I'm getting my little 2 up here. With that said, now let's go back and see what we got here. For my 3, what did I add? I added an x, and I added a 1. And again, I'll leave it there for now for the placeholder. It's silly, but it's fine. With the 4, what did I add to the denominator of the 4? I added a 3, and I added a 1. All right, now we cooking. For the 2, I added a 3, and I added an x for the common denominator. That's what I did. And now I can look at this and be like, boom, 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 that's gone. And now all I got to do is worry about this. Now all I got to do is worry about this. So I'm going to have 10 times x times 1, which is 10x. I'm going to switch back to black. Hold on. 10 times x times 1 is 10x. 4 times 3 times 1 is 12. Plus 2 times 3 is 6, times x is 6x. And holy crap, look what we got here. Now this is just a normal equation. Now this is just a normal equation. So now I'm going to subtract my 6x on both sides, right there, and I get 4x equals 12. I get 4x equals 12. And then that's what I have here. That's not a big deal. Oh, I have to divide, sorry. I'm like, what am I doing? Morning brain fart. X equals 3. So x can equal to 3. Hooray for us. Now, here's the weird part about these types of problems. 3 isn't a letter, so like it doesn't matter. It's just a number. 1 is just a number. X, we're going to set it equal to 0. X cannot equal 0. See how I took this x and just said x cannot equal 0? Is there any more work to do on it? The answer is no. X cannot equal 0. That's it. That's how you solve this. The end. Pretty cool. All right. I'm going to start on example 5 as well, too. I'm running out of time, though.